Assalamualaikum warahmatullahi wabarakatuh, and a very good day. So as for today, we are a group of students from section 4 and group 3 are going to present our experiment, which is series and parallel pump. So I am Siti Rahana binti Muhammad Saleh. So firstly, as for the background, pump is a tool that convert kinetic velocity of a fluid into head or pressure. The fluid will enter the eye of the pump, and then we have a rotating impeller that take or put some kinetic speed into fluid. Once the fluid is excited, the impeller, the volume is thick, and so fluid lose all its kinetic energy, which is converted to head. So based on the explanation, we can refer to the Bernoulli equation actually. So as for the series pump can be considered as series of centrifugal pump, that is to supply one another in series, thus progressively increase the discharge pressure. As for the parallel pump is a primary purpose of operating in parallel because it is allowing a wider range flow to be compared of flow to be compared to the series pump, and also with widely flow demand. In various industrial and commercial systems, we will see configuration of pump linked in sequence or parallel in water delivery network in order to respond to a wider variety of pumping height and flow range. The pump is the most insecure element in most pumping systems. To address the issue of the efficiency and also the discharge range in between series and also parallel pump configuration, the experiment is conducted.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Afiq bin Saidi, MA18158. I will present about objective and the scopes. Our objectives is to establish pump characteristic curve for a single pump, to pump in series and to pump in parallel by measuring head and flow rate using the experimental apparatus, and to develop theoretical pump characteristics curves for pump in series and also pump in parallel, experimentally derive single pump characteristic curve, and lastly to compare the experimental and theoretical pump characteristic curve for pump in series and pump in parallel. For our scope is the pump may be paired in sequence or parallel in complex system, and the heads are added together in series operation, and the flow speed of the pump are added in parallel operation. The two equivalent centrifugal pump and intake tank with overflow are used in the experimental unit. Regardless of the water intake, the overflow provides a continuous suction head in the tank. And lastly, the experimental device is placed on the work surface with ease and protection. The state of the pump inlet is essential for proper pump operation. To stop cavitation, the structure of the pump inlet side must allow a steady flow of fluid to reach the pump at sufficiently high pressure.
Now I will continue with the theory part of our lab. A pump is a device that moves fluids, that is liquid or gases, by mechanical action, typically convert from electrical energy into hydraulic energy. Pumps can be classified into two major groups accordingly to the methods they use to move the liquid, which is dynamic pump and the displacement pump. Pumps operate by some mechanisms and consume energy to perform mechanical work moving the fluids. Pumps operate via many energy resources including manual operations, electricity, engines, or wind power, and come in many sizes, from microscopic for use in medical applications or to large industrial pumps. Dynamic pumps are also called as kinetic pumps, and are either centrifugal or vertical centrifugal pumps are based on their flow direction, suction type, and mechanical construction. Positive displacement pump can be reciprocating pump, rotatory tape pump, or pneumatic pump. Reciprocating pump either use a plugger or pistons. Rotary pumps depends on how many rotors they use. There are single rotor pumps or multi-rotor pumps. Meanwhile, pneumatic pumps rely on the type of ejector. These different pumps have practical use and are dependent on your intent purpose. Pumps, after all, aren't only used for water. They are also used to transport food, oil, and other material. In the picture below, we can see that on the left-hand side is the centrifugal pump, while at the right-hand side is the rotary type of pumps that are under the positive displacement of pump. When we come to the arrangement of pump, there are two types of arrangement in the pump, that is series arrangement or parallel arrangement. First, we come to the pump in series. When two or more pumps are arranged in series, the resulting pump performance curve is obtained by adding their heads at the same flow rate, as shown in the figure below. Pumps in series are used to overcome large system head loss than one pump can handle alone. For two identical pumps in series, the head will be twice the head of a single pump at the same flow rate, as indicated with 0.2. With a constant flow rate, the combined head moves from 1 to 2, but in practical, the combined head and flow rate move along the system curve to 0.3. 0.3 is where the system operates with both pumps running, while 0.1 is where the system operates with one pump running. When we come to the pumps in parallel, it is when two or more pumps are arranged in parallel and their resulting performance curve is obtained by adding the pump's flow rate at the same head as indicated in the figure below. Centrifugal pumps in parallel are used to overcome large volume flows than one pump can handle alone. For two identical pumps in parallel and the head keeps constant, the flow rate doubles compared to a single pump as indicated with 0.2. In practice, if one of the pumps in parallel or series stop, the operation point moves along the system resistance curve from 0.3 to 0.1. The head and the flow rate are decreased. There are many advantages for both series pumping and parallel pumping. When we come to the series pumping, series connected pumps generally require less horsepower than one large pump meeting the same condition point, and it can also achieve a higher efficiency point. Centrifugal pumps in series allow for operation at lower speeds and has additional of benefits like reduced wear, lower energy consumption, increased reliability and longer life. Pumps are also smaller, easier to maintain and more manageable versus to a larger centrifugal pump. For the parallel pumping, the advantage is it can provide up to 90% redundancy of the design flow with a single pump, which equates to significant standby protection that supports the system when one pump is down. Reduce the motor size required for a standalone pump, making this redundancy cost-effective. Match flow to load better, which means a single large pump is not required to continually pump full flow against a control valve at high turndown. And lastly is save amps on motor starts for plants. They are restricted by demand charges or electrical entrance limitations.
So, Assalamualaikum. My name is Syed Kukman Irfan bin Tuan Kasbadi. So, I will present about the method and procedure. So, the method that we use is the system contains two identical centrifugal pumps that connect with pipes. Each configuration, which are single pump and two pumps in parallel, will be tested at pump speed of 60, 70 and 80 revolution per second. For each speed, the bench regulating valve will be set to by output valve. Time water collection will be performed to determine flow rates for each test, and the head hydraulic power and overall efficiency ratings will be obtained. So this is the procedure that we need to set up. So the first one, set up the apparatus based on figure 1. So this is the figure 1. We need to set up the experiment like this. So after we set up the apparatus, we need to open the single pump, which is we need to test single pump first. So the third one is turn the valve to the right. As you can see in the picture, we need to turn right to close the valve. And for number 4 is turn left to switch on single pump. So we want to experiment the single pump, so we need to turn left on single pump. So number 5 is we need to control the output valve to adjust the volume. So after we finish with the single pump, after that we use the parallel pump configuration. We need to turn on the parallel pump configuration. So when we used to experiment the parallel pump, we need to turn right to switch on both pump.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMED bin Ashron. My metric ID is MA18133. So I will be explaining about the chapter 4, which is the result and discussion for the pump and pump configuration experiment. For the formula used, I've used the velocity formula to find the velocity of the flow, which is the volume flow rate over the area. The volume flow rate has been given in the data, and the area has been calculated as the inner diameter of the pipe is 20 mm. Next, I've used the head net formula to calculate the head net for three pump configuration. I've cancelled out the elevation for both Bernoulli equation, and I have calculated the pressure difference between out and in. The velocity also has been calculated. The density of the fluid, we assume that the fluid is flowing at 25 degrees Celsius. So the density of the fluid is 997 kg per meter cube. So G is the gravity, which is 9.81, the gravity acceleration. Thirdly, we use the water horsepower equation to find the water horsepower. Rho G QH, which the Q is the volume flow rate, and H the head loss, head net. We also have the efficiency equation, which is power out over power in. We have converted the power out as given 660 watt into 0.8507 horsepower. So this is the table for table 1, which is single pump configuration. So we calculated the velocity first, then we calculated the pressure difference for the single pump configuration, which is doctor can look at the detailed calculation in our report. So we have get the highest net head for the single pump configuration based on the highest volume flow rate. The highest efficiency of the pump also have at the highest volume flow, which is 0.892. So we move on to the second series pump configuration. So for the series pump configuration, firstly we have calculated the velocity of the flow based on the data given. Next, we have calculated the total pressure, which is firstly we have calculated the total pressure of pump 1, and we have calculated the total pressure for pump 2, which is the P delivery minus the P suction for both pump. After we calculated both pump, we have added both data to get the total pressure. So this is our data, which the doctor also can look at our report as the efficiency. Next, the parallel pump configuration. So firstly, we calculated the velocity of the parallel pump configuration, and we have taken the outflow pressure based on the lowest delivery pressure that have been given, which is the at pump 2. which is the P delivery lowest is at the pump 2. We have calculated the net head and the water horsepower. Also, the data is also have been calculated in our report. This is the efficiency of the parallel pump configuration. Next, we have used the graph. So for my calculation and the graph, I've used the Excel, Microsoft Excel to calculate the data. So this is the single configuration pump, which you can see that the higher the volume flow rate, the higher the net head. Also, the series configuration pump and the parallel configuration pump also show the same pattern. So for the discussion, the volume flow rate is directly proportional with the net head. All graph has the same pattern as the same equation has been used. It is following the equation that has been used. The parallel pump has the highest efficiency. The single configuration pump has the lowest net head in this experiment. And the series pump has the highest total pressure calculated. So this is some of the data that we taken from the internet and the video given by the doctor, that Q for series pump is equal to every pump, and the pressure for the total pressure for parallel pump is equal to every pump. So this is some error that we have taken. So that's all from me. Thank you, doctor.
So here I want to present the conclusion. So from this experiment, the result and the graph show the performance curve that show to us when the volume of flow rate increase, the net head will decrease. The pumps configured in single, parallel and series statistically increase their respective capacities in terms of static delivery head and discharge volume flow respectively. So when pump is connected in series, the volume of flow rate is nearly same as single pump, but they will increase in net head. When pump is connected to parallel, the net head will be increased, and the volume of flow rate also increase as well.